to set up a new visualization centre. That's how you build your end. Basically, we were given the task of sort of setting up this centre, buying some equipment, putting the equipment in there, and then we have to provide a visualization service to academia and industry. And so we also have to operate commercially, so we have to make a profit, basically. And we were given some money to kind of get going in the first place. So I'm just going to talk about some of the work that we do at C3D. We've got I'll show you a few pictures of the building. So that's the building where we work. We've got loads of space, we're very supportive. And then, so we've got two theatres. We've got upstairs, we've got just a small theatre with a very high performance projector and surround sound. And then downstairs we've got a power wall with two large high definition screens, edge blended, with stereoscopic display capability. And then we've got a flock of birds, an Ascension flock of birds, which is like a motion tracker, so we can do work with motion tracking. And nice surround sound, so really nice facilities. And then we've also got a render farm, so we have Sun did a deal with us and gave us a whole load of Sun boxes, so we've got 24 nodes of Sun processing power, and then we've also got an SGI Prism, which drives all the kit in the theatres, so that's an amazing machine. It's got like 56 gigs of RAM and 28 processors and an amazing thing for compositing, so you've got like 14 graphics cards in it that can all output to one display, and that kind of thing. Okay. And we've also got, a hemispheric, which we haven't used it very much yet, but it has a 180-degree display, and it's a nice bit of kit, but we're not quite sure how we're going to use it commercially. So we've only moved into our building about not even 6 months ago, 3 months ago, and so then, but a year ago, the team that work on all the animations and things that I'm going to show you in a minute, we all started work about a year ago. Most of us didn't know anything about Blender. We didn't know much about animation. So we came to this conference last year, very much newbies, not really knowing anything about anything. So it's quite nice to be able to come back and show you some of the things that we've been doing. So the next thing I wanted to talk about was get it in the right place. We've created a bunch of render farm scripts that might be useful to the community, so we're going to put these up on a website. If you're interested, you can have at them. So I decided to try giving a presentation of the movie and explain it a bit differently. Okay, so we don't really know what to call it. Internally, we've been calling this render farm script Render Master, but then when we looked on the web before we came to the conference, it seems there's already something called Render Master, so we called it YARF for now, which is yet another animation render farm script. But it's quite cute. So basically, you set up your blend file just the same as you would to render on your own PC. You run a Python script, and then you can see here, you just enter in your username, start and end frame. You can give it a priority, so if you've got some work that's more important than other stuff that might already be running on the farm, you can give it a priority. Type your email address in and it will send you an email when you finish the job. And it will also send you an email sort of in 6 weeks or something to tell you that maybe your work's going to be deleted if you don't take it off the render farm. And you can also, more recently, we've added in sequencing so that we can output stuff from the sequencer via the render farm as well. So basically, you type all that in, press render, and it comes back with the job ID. which is just a number. And then to kind of monitor and see what's going on with your render, we basically get the render farm to talk to an IRC channel, and then you can log into that IRC channel, and then you can ask it things about what's going on. So you can see there, I've asked it, what clients are connected, and you can see all the Sun machines and the SGI are connected up. You can ask for the status of the job, status of the render farm. You can kill jobs, pause them, add new clients and kill clients. Sorry, render nodes only. And that's it really. And then it tells you bad jokes as well. So basically the way it works is you have one central, you run a render master script on one machine that's like the master script. It has a connection to a MySQL database where it keeps track of all the jobs that are running and all the information about them. All the scripts are written in Perl, so they'll run on Windows or Linux. And then you have, for all the nodes of your render farm, you just have a client script and one config file, so it shouldn't be too difficult to set up. The main render master script talks to the IRC server, and that's how you communicate back with it. And then where we are, we use shared storage, so everything's mounted under NFS. So we could all have, we basically, that's how we get access to get the files back from the render. Can't think of anything else to say about it, so that's the render farm. Okay, so this is quite a long animation, so I'm just going to talk over the top. Oh, hang on. I'll talk about this first. Basically, when we started, we kind of looked at different market sectors and tried to identify where we could do some work, basically. And our business development manager ended up talking to a few wind farm guys, and they were saying how they have to produce these environmental impact assessment reports before a wind farm's built. So essentially, before you get a wind farm in Britain, it takes like at least 2 years, if not 5 years, before the thing gets built. And before that, there's a whole load of, they do as much planning as possible. And there are quite a few people that really don't like wind farms, so you have to address all their concerns and that kind of thing. But there's a whole load of wind farms going up in Wales at the moment. They're trying to meet their targets for emissions. So essentially, this is the kind of thing they used to do when we first met them. So we kind of wanted to see if we could help do what they were already doing. So here, somebody's gone out into a field near where the wind farm is going to be, taken a grid reference, taken a photograph, and then we've montaged on top models of wind turbines. And then at the bottom, there's kind of documentation that talks about how these environmental impact assessment reports are supposed to be produced. They like to have these, the lower one, the kind of wireframe kind of look. So we did that, and then at the bottom you can see which way the camera's looking and the field of view. So here we just thought we'd take it a bit further, and we overlaid some ordnance survey on top of the terrain data, and it's the same kind of thing really. And these are quite interesting. So one of the things they produce are these theoretical zone visual influence maps. So basically what it is the different colours tell you how much of a wind farm you can see from that location. So here, everywhere in dark blue, I think you're supposed to be able to see just a couple of wind turbines, and then everywhere in red you can see virtually all of them. So they use this as quite a quick way of identifying where trouble spots might be for people who object to wind farms or whatever. But I don't think it's very intuitive. It's quite hard to read unless you're used to looking at maps and plans. So, we took this and we decided that it'd be much better to have like a 3D animation where you could fly around the wind turbine site. So in order to do that, we had a whole load of data that we had to get into Blender, and that data can come in loads of different formats. But essentially, we have terrain data, which is usually comes in Britain. You get NTF files. They're essentially just grid-referenced spot heights, and they have them on a massive grid. And you've got what I think it's accurate to the millimetre every 10 metres. But then you'll get hundreds of these files. So we use a piece of software called Global Mapper, which is a Windows-based thing. We couldn't really find anything appropriate that was open source or free. And it's a great tool. And basically what we do is we load all the data into Global Mapper, chop it up into tiles, and then export it back out as STL files, which we can then import into Blender. We have to do a few tricks with... so then after we've done that, after we've got the terrain data in, we'll do the same thing with aerial photography or satellite data, or if we want to use an OS map, we'll put that into Global Mapper and export it out. Turbine models we usually make from plans if we've got them available so they're accurate. Site boundaries we can mark out in Global Mapper and then export paths back into Blender. It's also quite useful, but soon after this I'll show you there's basically a camera track following the road, and so for that Global Mapper is really useful because you can plot out the path in Global Mapper and then export it into Blender, and you've got your camera track ready to go. Because the other thing with this is because we're doing it commercially, we often have horrendous deadlines, so they'll sort of bring us up the week before and say, can you do this for next week? And we'll be like, we'll try. So anything that can save time is good. What else to say about it? So basically because this one's not so big, but some of the ones, more recently we've done some work where we've had an area of about 600 square kilometres of terrain that we had to have in our model. And obviously Blender's only able to handle up to 2 gig in 32-bit, which is what we use at work. So the way we cope with that is to have... Can you hear me? Can you hear me all right? It's gone off. I think it's gone. Oh, okay. I'll just talk loudly. So we use proxy. So basically, we split all the data up into tiles, and then we have proxy objects that are lower resolution that we use when we're manipulating the blend path, and then we can swap in the higher resolution tile when it's time to render. And we do the same thing with multiple materials for each tile, so that we can have a low resolution material when we're working on the blend file, and then swap in a high resolution one for the render. A bit more interesting things to say about this. In the bottom right hand corner, it's a map of the area, and the arrows explaining which way the camera's pointing relative to the map. The colours, I don't know how well it's coming out here. You can't really see on here, but because the colour quality isn't so good, but there's actually, we superimposed the zone of theoretical visual influence information over the top. So, just as a way of sort of comparing how much easier it is to see how many wind turbines you can see from the location, just by looking rather than having to try and work out the zone of theoretical visual influence. Okay, so I guess that's pretty fun. this last bit is just a bit more of how ways we were experimenting with presenting the data. So here we've got one of our 3D models loaded in, so animated so you can see it. But then what we're going to do is play and compare to a photograph taken from the same location as the virtual camera. So it's just a different way of doing these kind of photo montage things. So out of all of these kind of different ways of playing with GIS data to produce stuff for wind farm developers to help with their planning, it was really only the fly rounds that were commercially viable. But it's good because they weren't doing them, and now we're getting quite a full client list of people who want wind farm visualizations to take to public consultations and planning meetings. So there's a bit at the end here of some of our more recent work. So this was the one with like 600 square kilometres of terrain data, and then we also started adding forests in. And some people have asked us if we can put ditches in where, like cuttings in the road, because at the moment what we've got is something that always shows the worst case scenario. So we never, we always have to err on the side of caution and not do things that might be interpreted as making the data look pretty so that the wind farms don't make such an impact. So, for example, we can't do things like do any Photoshop or GIMP work on the aerial photography to make it look nicer, because sometimes it's really bad looking. Okay, so that's wind farms. The other kind of work that we've been doing is we've been finding people who want to do historical reconstruction. So they've got I'll show you. Okay, so this first one was a really early work. We started this one in about November, so we really didn't know much about wind, and so I hope you can tolerate it. Basically, this is Hardwick Hall. There's a large estate with a big mansion on it that's owned by the National Trust, who own lots of historic buildings and land in the UK. They wanted us to basically they wanted to change the way the public came in. So the public came in a completely different place to this and approached the main building along a sort of grand driveway, but they wanted people to come in around the back. And this is where all the workers used to live, sort of like the stonemason and the ironmonger and all those guys that worked for the people who lived in the mansion. And they wanted to turn this place into the kind of place where people come and, you go to the visitor centre, go to the loo, have a picnic, all that kind of stuff. But because it's such an important building, they have similar planning issues to wind farm developers in that they have to do horrendously exhaustive preparation beforehand to show what they're going to do. So in this case, what they've done is they've gone and taken a load of photos of all the old buildings in this courtyard and surveyed it. And so we were given a whole load of drawings and a whole load of photographs. And what they wanted us to do was to basically create a 3D model, but to keep all the details. So where you can see funny shaped stones and kind of all the fittings, everything in this model is as accurate as we could make it. So they're not just generic stones, quite often they're specific stones that are exactly like that. And then the intention was, in the future, was to do a as will be and show how the new visitor centre would have looked. But we haven't done that yet. So it was quite good fun. We had problems here with ambient occlusion. We didn't really understand how ambient occlusion worked, and we had it all set up nice, and the stills were coming out really nice, but then when we animated it, all the shadows were flickering, and we didn't have much time left because we were on deadline, so we just reduced the ambient occlusion and it messed up all the lighting, which is why it looks a bit flat. But you learn. This one was more recently completed. Basically, there's an aqueduct in North Wales called Pont Silspen, and we went to these guys, the Royal Commission for Ancient and Historic Monuments of Wales, and said, is there anything we can do for you? And they told us that they'd been trying to build a model of this bridge in AutoCAD, and they were having lots of problems. Firstly, they couldn't hold the whole of their model AutoCAD because they were running out of memory. And so they had kind of lots of bits of models, and also they had no idea how to go about animating it. And essentially what they were trying to do is create a video that would explain how this aqueduct was constructed and use it to present a case for making it a UNESCO World Heritage Site. So they wanted to be able to have something pretty to put on the screen while they talked about all the, how, you know, why this place should be a UNESCO World Heritage Site. So we basically took their data from AutoCAD, exported it into Blender, textured it, animated it. Unfortunately, we couldn't bring out stereo display. More recently, one of my colleagues has created a stereo version, which is really exciting and fun to watch. So it's quite a nice animation, I think. So I can show a bit more. So more recently we've been commissioned to do some work on, there's a castle in Carmarthen in South Wales, and we're going to create an animation that shows the history of the castle from when it was just like a wooden fence around on the top of a hill to present day, where now it's got county council offices built on it. So we're looking forward to getting started on that one. I was kind of hoping I could put some music over the top, but I didn't have time. This one apparently might get used in a documentary that's being made next year. So we might do a bit more work on it. Okay. So this is a bit of a joke, really, because the guy who commissioned the work said he wanted the horse pulling an old-fashioned boat across the aqueduct, so we kind of tagged it on the end as a bit of a joke. Okay. So the next piece I'm going to show you is something we've done for a company that makes controller units for factory production lines. Basically, this is going to end up as a bunch of clips on a Flash website, and you're going to be able to sort of press buttons to interact with it. So I just compiled a whole bunch of parts of the sequence into one sequence so that you can kind of watch it. With this one, we were basically sent, I mean, the first time they sent us some files, we just had one of these, well, you can see that kind of unit with the green on it, it will come off later. We had one of those as a kind of test thing, and they said, you know, can you render that for us, and then we'll see about giving you the whole job. So one of these units here. So we did that, but we had, I think there were step files from the company, so it was a bit of a weird format because they used Pro Engineer. So they didn't have a complete prototype at that time. So we just had to work from that. So we basically the next time we found the ProEagle that we got some data from, we found the ProEagle export 3ds Ultra files, and they're a whole lot nicer to work with than the step files. The step files made really ugly meshes in the Blender. It was just taking too long to clean them up. So this was quite good fun, because then partway through the job we actually got one of the units from the factory where they make them. So we took photographs to get some of these textures that you can see, and that seemed to work quite well. I wasn't sure if just literally just getting a camera and taking a picture was going to be good enough for the texturing, but it worked fine. So it's quite nice. To say about it. So basically this is like just a control unit. You plug your motors that control the factory production line into this unit, and then you can swap in and out all these kind of different modules that let you do different things. So you can program them, you can get them to talk to each other, connect up other weird bits of kit. And I guess here they just wanted to say, you know, you can remove the fan, you don't have to undo the whole unit and that kind of thing. Sort of more generally, we really like Blender, and it's all that we use for 3D animation. We occasionally have to use 3ds Max with AutoCAD files to get them into object format, but that's about it. Okay, more recently again, because we do a lot of different kinds of work, we've been working with a biologist who teaches in the university, and they want to create an interactive web page where they can have models of embryos that you can interact with, rotate, kind of generally have a look at, and then also show some photographs of cross-sections of the embryo, and then have some questions about it underneath, sort of in a web page, so that they can round all the students up into a room and give them a test and assess the model. So this is kind of the start of. So this is a model of a frog embryo before it becomes a tadpole, basically. And eventually, it was quite interesting to see. Was it Thurston? I can't remember the guy who wrote 3D MP. That gave a talk yesterday. So we're going to use that as a way of embedding this in the web page. But it's something that's coming up quite a lot is wanting to be able to embed 3D models in a web page efficiently. I mean, the problem with the 3DMP method, which is where you have a JavaScript basically program running inside a web browser that loads images so that when you interact with, you kind of interact with the image and it changes it depending on where you drag your mouse. The problem with that method is that you have to have, sort of to get a decent, smooth rotation, you need about 300 pictures. And that takes a long time to download, and then if you start compressing the images to make it a quicker download, then you lose the quality, and it kind of is a bit of a problem. But on an intranet, it's not really a problem because it'll load so quickly. So this one's been quite fun. Originally, there was going to be subsurface scattering going on here, but to get it to render in time to show you today, we had to change the way it was rendered. This is the last stage. And there's some seams here as well, which didn't show up when we had the subsurface scattering. UV map seams. Didn't have time to clean them up. Very strange looking thing. So I think this is at about 14 weeks by the time it gets to this stage. And then about a week later it's a tadpole. But that's the end of that. I'm doing for time. Okay. I'm going to show you something now. I have to tell you a story really of how it came about to explain why it exists. We were going to construction companies and asking them if we could do sort of architectural visualizations for them. And they were saying to us, they were kind of, yeah, okay, that's fine. But they told us this story, a very large construction company told us this story about how they build supermarkets for a very large supermarket. And basically what happened, they had very short turnaround cycles between being commissioned to do the work and building the supermarket. And what tended to happen was they'd say, I want 12 supermarkets in these locations, and they don't really get any plans, so the construction engineers kind of, what they get is a load of kind of marketing gump that kind of says, colour schemes and kind of photos and that kind of thing. So then the construction company design plans, show the plans to the supermarket, but the supermarket doesn't really look at them properly. Then the construction company virtually finishes the supermarket, and then all of a sudden the manager from the supermarket decides he wants to come and have a look at the building. And then he starts saying, well, that's fine, but can you move the toilet to the other side of the building? Can you move the entrance over here? And then, because the supermarket is such a powerful, much more powerful company than the construction company basically just have to do it, and they don't get any more money. So for them, what they wanted was a way of visualising the building before it was built in a bit of in a very easy way for in a piece of software that managers could use, so that they could go for a walk around the building and kind of move a few checkouts around and that kind of thing. So we built this with Crystal Space underneath, and then it's got WX widgets, user interface, and then we build all the models in Blender. So basically you can kind of go for a walk around the supermarket. But then what's cool about this is that it can generate a 2D plan from the model. So here you can see a model of the supermarket. The red triangle is a poor icon for a camera. And then we can kind of move things around. So I can select something, grab it, plonk it down. So it's very simple at the moment. It's just a kind of proof of concept. You can load new worlds. You can load catalogues of things. So it's all very beta at the moment, but I'll show you. So here you can have a library of, I don't know, different kinds of shop furniture and add it into your world. So at the moment it's just got crappy names, but it works. So I'll plonk that down there. And then you can quickly go back into 3D view and see what you've done. So that's quite cool because managers don't want to have to learn how to drive AutoCAD or Blender. So we were trying to get something simple that they could play with that would do the job. And then we've had other ideas. So this can also work in stereo if we had a stereo projector. It can communicate over the internet, so you can have one person at one end of the internet driving it and the other person at the other end looking at it. And then also, we had this kind of idea that we might want to write plugins for it, so we've kind of designed the whole thing so that we can plug stuff into it quite easily. That's that. Any questions? I could talk for hours because there's loads more things. Anybody got any questions? Okay. Thank you very much.